Alright. On to the funk music. Aye. Okay. Show. I do actually have to write the tests. Right. I was gonna do that. I was gonna compare it against the Lua code instead of writing a test. I guess I kind of did write a test, but it is more of a full algorithm test. I boiled my coffee in the microwave by accident. That's fantastic. Where is the branch? Ugh. I kind of want to put this in the other one as well, in the push solve. M. It's interesting that it allows that. Okay, so I don't think I need to test the determinant function. um, okay, I do need to test reduce 3. So ideally I would have like 2 cases here. And then 2 times 2 cases here. And then 2 times 2 cases here. So is that 6 cases? I don't really want to think that deeply. I just kind of want to like test it according to my knowledge of how it works. So I'm gonna do that. Let's try it. All right. Oh, cube. Ew. Well. Oh. Well. Mo. Oh. Oh. Mesh is an argument. So I can't just. What if I pass the mesh vertices as arguments. Oh yeah, that is cooked hard. Oops. V0. Okay, it has to return the simplex indices or the vertices. But it also has to like calculate them, you know. Oh, wait. Oh. That's not allowed. You can't do that, right? I couldn't say like 0 P1 P2 equals simplex dot map. Oh, I don't have simplex. Okay. All right, never mind. Mesh query, huh? Yeah, mesh query. So why don't I try? I have to try. That's the requirements for this. Test reduce 3. No way. So I need to make a dang mesh, which could be a challenge here. Mesh data, basically. You can do mesh from model mesh, but it's not like a good way to construct the old physics mesh. Physics mesh data is faces and vertices. Physics mesh topology is this other crap. Really? Hello? I'm trying to construct a physics mesh. Topology. Directed edge. Whoa. Okay, why don't I make a little function here? Haha, unit cylinders, unit cube. That's stupid. Um uh test. We'll do pub create, I guess. Test triangle. Actually, no. Tetrahedron would be better. Although triangle, I'll probably just start with triangle. Oh boy, so there's there's one face, and that's it. Physics mesh data. Go gadget debug mesh print. Yerp. Oh. Why is it tabbed that way? Don't be doing like that. Okay, so we have faces and we have vertices, and there is 3 vertices. Oh my god. So it's gonna be some of these. Some of these will be vertices. mm. Is this const? Why is it not const? So how should I do this? Okay, how about negative XYZ and then positive X, positive Y, positive Z, and those are my vertices. So we got this guy right here. That's triple negation. And then one X positive, one Y positive, and one Z positive, Z. Okay, so we have tetrahedron. I'm gonna need to plot this. Okay. 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 So then the mesh topology. Uh-huh. Just like that. And then this is like this. And everything is fantastic. Wow. So I do actually need to list two faces. So, geez, I'm gonna do. I'm just gonna go with Y, cause like that's what I know from Roblox. You use Y. Okay, so we got face positive Y, face negative Y. I don't know. I don't know how to do this. I always just auto-generate it, man. Are the faces... Are the edges clockwise or counterclockwise? Huh. I don't have any invert parity. I do, but all traits can't do it const. Okay, so if I'm doing Y, I won't have this Y. Face. G. Okay, so faces are gonna look like this. Edges are gonna look like this. And vert are gonna look like this. Did I write down what the goddamn hell you have to do? Okay. Blah blah blah. Face. Faces. Okay. Mapping. Submesh face. Faces mesh. Face refs. I didn't write it down. Oh my god. So the face will either be clockwise or counterclockwise, and I didn't write it down. God, man. You have to write it down. It's a directed edge. Oh my god. I didn't write it down, but I assume the edges are directed in if you're looking towards the normal, that's clockwise. Clockwise when looking towards the face normal, i.e. right hand rule. Okay, so then what does that mean? That means that we're going to have edge 1. Oh, that's 0. 0, 1, 2. And edge face 0, 1, 1, 0. Say goodnight. That's nice. Faces. Face, face. Verts. Vert, vert, vert. Thank you for writing it down, Quat. Vert refs. So each vert will have 2 faces, I believe in no particular order. And then the there's 3 edges. Oh. Okay, so if we're directed along the edge like this, then the left face is face 0 and the right face is face 1 for all 3 edges, and the the first edge, let's start at vertex 0 and go to vertex 1, start at vertex 1, go to vertex 2, start at vertex 2, go to vertex 0. So it goes Well, it's gonna be this way, so Okay. Okay, if you say so. Okay. So then that's one face, 0, 1, 2, and then 3 edges. Face topology. Wait. We have 2 faces. What do you mean? So this one is reversed. So I'm doing and instead of negative unsigned abs. Oh. Yes, because I need this because 0 is also directed. You can have edge 0 go this way and edge 0 go that way. So negative 0 is not 0, so it's not the same as negating the number. You need to have the like signed bit and then the like 32 bits, 31 bits of the number. One bits minus 1 sign bit. That's a sign bit. A sign. Okay. So I'm adding a trillion, basically. Right. So this one I'm subtracting a trillion, and this one I'm adding a trillion. Okay. Okay, if you say so. All right. I believe you. Okay, so then this one, bup sign bit, bup sign bit, bup sign bit. So all of these are directed in the other direction. Wait. But they also have to move in the opposite direction. So I gotta like 2, 1 this. Right? Why are you trolling me? Oh, I have a little goober here. Oh, am I chill to just do this? Is that okay with you? Whew, okay. What are we cooking up today? I am cooking up a triangle. This is a triangle. Wow, that's a triangle. It's gonna be such a good triangle. It's gonna be the best triangle. The triangle. Okay. Triangle, not a circle. My game actually does not have circles. Believe it or not. Actually, most games don't have circles. In the like mathematical sense. Okay. Okay. So the vert. Yes, you need to say which vertices have which faces. I know how to do this. So the faces are in no particular order. 0, 1. Okay. Wait, this dot product is negative as well. In it? Because it should be the same. N dot p equals d. If I flip the n, I also need to flip the d. Okay. Okay, okay, edges. So now the edges of the vertex are it's a thing. Something happens. So let's look at the edges here. So edge zero starts at vertex zero and goes to vertex one. So if we are on vertex zero and we want to know the list of edges, well, edge zero is one of them, just like as is, in the same direction as it's defined here. It's directed in the same direction. But vertex zero also connects to edge 2, edge ID 2, which is the third edge. Which starts at vertex 2 and ends at vertex 0. So vertex 0 here is connected to this edge as well. But it's in the opposite direction. So it's edge 2, but with the parity flipped, going in the opposite direction. And this is actually how all three of them are going to be. 0, 1, 2. 2... 1, 2, 0, 0. Wait, 1. Okay, so let's think. Okay, this is vertex number 1, which is the second vertex, which is this one. It doesn't matter though. Vertex number 1, and this is edge number 1, which starts at vertex 1 and goes to vertex 2. So if we're listing the edges of vertex 1, it would be edge 1 and edge 0. So edge 1 and edge 0. But edge 0 is backwards from vertex 1's perspective because all the edges point out. I should actually write that down right now. Clockwise, baba booey. And then edges are always directed away from the vert. Faces have no particular order. This is left, right, bottom, top. Wait, bottom, top. Wait. Submesh vert ID. Wait. Bottom, top? Oh, bottom, top. It's the edge refs. The start, end. Okay. Oh my god. Okay. Did I do it? Did I do it? I think I made a triangle. I think I made a triangle. Okay. Should be good to go. I'm there. Okay, actually I need to do the cross product. Oh, okay, so at the first the faces don't know their verts? Huh. The faces don't know their verts. I guess it's kind of duplicate information because the edges. Oh, I see. So, okay. No, I see. So, the edge ID is well defined, but you can't get the edge ID from the vert without doing like a scan. So, I define it in terms of edges, and then it also well defines the vertices because you can just take vertex 0 of each face as you go around. That makes sense. What a smart guy. I should write that down. Verts are unnecessary. Duplicate information. It's like redundant. Use edge I0. Dot verts. Yeah. Okay. Okay. Did I do it? Did I make a freaking triangle? Triangle. Triangle. So I have a triangle. No worry. So does it include the point? I'm curious. Oh. Isn't this like... Sounds like Blondie or something. Doesn't it sound like Blondie? Okay, so we have... Well, let's do negative y. It should include negative y. It draws through negative y. I actually don't know what it's going to do. I expect it will just fail. Yes. Strafe. Strafe? Engine physics. Yes. Cargo test release. Boom. Boom. Fail. Failed. Okay, I expected that. It shouldn't fail, but it does. Why don't I CFG test this? Okay. Okay. So I'm gonna do... Honestly, I think I'm gonna write down the other stuff. Okay, hold on. Triangle test. No way. So we have a triangle. Yeah. And then I'm gonna document and physics mesh. Thanks. Please document it. Please. Okay, so this is not the test that I want to do. So let verts equals mesh. Can you just mesh dot verts? No, you can't. You have to do mesh view dot vert. Wait, what? You can't just like grab them all? Vert. Didn't... Yeah, look at that. Huh. Huh. Okay. Physics mesh view. Yes. Physics mesh view. No. Oh, wait. Oh, is there no impl block? Go to implementation. Oh, okay. Okay. Impl a physics mesh view. And then we can have a verts function, and it can actually just use this lifetime. Okay. Okay. And it's gonna be a slice of verts. Oh, the position. Oh, that's not good, man. Submesh vert ID. Oh, that's me. Data dot verts, and this is not the right return type. Vert. And this has. Oh. Mesh vert ID. What? What? It's goddamn private, isn't it? Submesh vert ID is private. My tests. I need submesh vert ID, but I have mesh vert ID. I can't get it. I can't get it. I can't get it. So I have this list and I want that list. I guess I can just return this and like troll. I can be like, whoa, ha, whoa, whoa. A. What do you mean A? Only used once. Okay, whatever, man. What do you got? Vert. Right. Topology verts. Alright, I'm gonna make it crate for now. God damn it. Maybe I'll unuse it. Expect dead code. Haha, lol. And I guess I can do that on the CFG test. Okay. Okay, so I get this, but I actually don't care. All I care about is the sub mesh vert IDs. Yeah, okay, so let's go to the test. So verts. Let's go. Okay, so I don't care, but I can't craft it. I guess I can index and compare. No, vert is grabbing the It's the this function grabs the position. So this is like, yeah, these are two different things. And I noticed that in my rewrite over here. Let's rewrite the physics. Very funny. And so I have mesh topology, that is topological queries, and I have mesh query. I wanted a better name for it, but I couldn't think of something that is like, where is this vertex in physical space? What is the normal of this edge? What is the normal of this face? And it has like the this actual real stuff, and that would make more sense. But that's rewriting the physics and blah, 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 you know. Okay, I can do it later, maybe next year. I just want to like make it so you don't fall through the ground by the end of the year. I don't have a lot of time. The triangle. This can I even um e okay. I'm gonna make a goddamn function. I'm just gonna do this. So vert freak self. It's gonna give me a and I'm gonna compare it to the vert ID submesh vert ID mesh vert ID. Boom 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 boom, like that. That is how it goes. And this is just this entire guy. So I only care about the topology when I'm like doing this test. I'm like, if I have my triangle, how do you make a triangle with your hands? If I have my triangle and I'm like, where is the closest point to here? I should be like, oh, it's this edge. That's how it should be. Yeah. This is. I gotta move this code actually. I'm gonna move it here. Is that not allowed in the mod? That's right, because this is a private field. Unlucky. Okay. Undo. We put it back. So vert. Okay, I just need to start writing it. Okay, verts. Nobody cares. Nobody cares. Nobody cares. So I am crafting a simplex and calling reduce 3. Um. Ah. 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 It has to be the submesh ID, and I can't craft it. Minimum difference. Closest 590 side. So how do I do this? Mesh. Hi, I'm the mesh. So I just straight calls it. It goes here. Mesh. I'm the mesh. Hi, I'm the mesh. Hint point. Initial axis. Farthest vert. So that gives you a vert. Okay, screw it. I'm making scoobers. Okay. Vert. I need this. I need this. Impl but impl public function. We'll go create function new. ID U32. Self ID done. Oh my god. Oh. Oh my god. It already has it. Okay. Is that a pub function? Okay, well that actually makes everything way easier, and I don't need all these goober functions. I did not realize that. I actually don't think I need any of this. Okay, so now I can make a scoobert. I can say submesh vert ID, and then that. I don't want that there. I'm just gonna put it like right here. Use create model, and then this is new with 2 colons 0. Okay, so our simplex is 0 1 2. No way. And then our mesh is this mesh view. We can call this complete mesh with 1 underscore, and then call this mesh, and then now that's mesh, and then point. Oh my goodness, so nice that there's a point. So our point is vector 3 new. What? And then okay, P64 1. X -1 1. Okay, so this is our triangle is on negative x, negative z, negative y. The right angle. Okay. Prop. Let's use a prop. How can I red, orange? Okay, so let's go. White is positive x, blue is positive y, red is negative z. So then positive z is this way, orange. Positive, positive, positive. So that means that our triangle is down here, and it goes, and it goes across the bottom, forms a triangle like that. That's our triangle. And then what I'm doing is I'm making this point, and I'm expecting that it returns this edge, which is edge number. Let's go see what it is. Model. Where is the edge? Okay, so this is edge number 0. Then we go to x. Then we go to Okay, so we're on negative all 3. Vertex number 0 on line 239. And then we go to positive x. And then we go to, I think this is backwards. Yeah, I think it's backwards. Because it has to be clockwise. Okay, so we have to go to We have to go to negative, negative. Yes, we have to go to positive z first, and that is clockwise edges in the direction of the face. So the does the other test fix if I do that? Yeah. Does it fix? All right, what do you want? This function is incorrect. You're lying. You're lying. Oh, okay. So it just wants a semicolon? God damn it, man. Okay. Expected a reference. Okay, buddy. Let's see what happened. So, reduced equals to this. And then this is going to be something. Reduced 3 reduced. Really? It's reduced. Oh, okay. Simplex. Yeah, no, that makes sense. That makes sense. That's good. That's good. That's good. So we want exactly a result. Exactly. Exact result. An exact result. We want assert matches. We can't. It doesn't have eq. We'll do assert and then matches. Reduced. Simplex 1 3 2 an array, and then it'll be these two vertices, and that's it. Except it's wrong. Haha. Yes. Okay, we need reduced. Submesh vert ID. I forgot. How do you do dir? 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 Dir. Dir. We don't care about dir. So it's reduced. We don't care. And then simplex. And then here. And it doesn't know anything. Reduced dir simplex. What? Oh, does it have to go here? Okay. Okay. Tuple or struct variant. Oh. What are you working on? I have to think. I'm sorry. I can't answer. So I need to have this in this form and pub create it. Oh my god. Let's say pub create just for this test. Okay. Okay, I believe I can answer now. Okay, what are you working on? I'm working on a physics system. It's like the nitty-gritty details. It's like a complicated algorithm to find the closest point. So you have a point, you have a mesh. What's the closest point on the mesh to that point? That's what the algorithm does. And it doesn't work. And I'm trying to figure out why. Okay, let's run the test again. I expect it to fail, but it would be nice if it passes. Because I swapped the parity of the mesh. Yeah, negative z, assertion failed. Mesh, yeah, okay. So it didn't work, but it would be nice if it did work. Okay, so when now we run this other test, and it probably will also fail because I'm probably wrong. Okay, so what did he say? Matches. Yeah, okay. Eek. Does this have eq? It does. Okay, so I ran this algorithm and something happened. What I would expect to happen is it would go onto this edge, but I don't know what this ended up as. Why don't I freaking like just debug it? And I can see what it is. Wouldn't that be nice? Unsatisfied trait bound. Oh, god damn it. Surely this time. Whoa, whoa, whoa. Simplex 3. That is unexpected. So it shows the positive Y direction. Why would it do that? What was my point? My point was this way. Oh, am I thinking backwards? What if I just make the point negative? What happens then? Turned off my stream. Hi. I have a new test and it's failing. Let's go. I'm trying to test these inner functions. This is what I was trying to do yesterday, and I kind of just didn't do it. Okay, so let's go big in the negative x direction. No, positive x. No, negative x. It has to be negative x. Let's look at the triangle. Okay, so I have made a beautiful triangle. It is beautiful. This is a square. This is a cube. This is a triangle. That's a triangle. So the triangle is a convex mesh. It has two faces, one here and one here. It's flat, and it has three vertices. Wow. Okay, let's orient this. Okay, white is that way. Okay, so this is positive x, positive y, positive z. So the first vertex is negative all three, so it's over here. And then the second vertex is positive in the x direction. And then the third vertex is positive in the z direction. So we have a triangle that goes like this. So by choosing negative x, I can find that this edge is closest to the triangle. And that makes sense to me. And that's on God. Okay. So let's... Why don't I, like... have multiple? I'll just go like this. And then... I'll just do it again. Okay, so I'm going to call this test... hypot. And then this test shall be called which edge is that? Oh, where did it go? Well, where'd it go? Why are we all the way over here? Edge 0, 1, 2. So there's three edges. Edge 0 is from 0 to 1. So that's from 0 to 1. And then 1 to 2 is the hypotenuse. 1 to 2 is the hypotenuse. And then 2 to 0 is the one we expect. We expect 2 to 0. But it might say the opposite way. But I might be wrong. Okay, so edge 2, which is 2 to 0. No way. Okay, so we are grabbing a vector in negative x direction, and then I would also like to times it by 2 just to see if that helps. And then we expect right here. Definitely. Oh, really? Did I not define it? I have to right multiply? Oh my god, bro. Okay. Plus Z back breaks my brain. Do you use Z up? I'm from Roblox. In Roblox land, Y is up. All right, run it. It's broken. Oh, we got a 2. 0, 1. 0, 1? What? Okay, so we have 3 vertices. Let's go. 0, 1 is here and here. And we just tested negative x. What's the closest to negative x? 0, 1. No. No. The triangle goes like this. 1, 2 should be closest. Oh, 0, 0, 2, 2, 0. So I have simplex here. The closest point algorithm, which is called minimum difference, works in terms of lists of vertices, which is a simplex. A simplex is a point or a line or a triangle or a tetrahedron. So depending on how many points you have in the list. So 1 is a point, 2 is a line, 3 is a triangle, and then down here 4 is a tetrahedron. So it's kind of like it's crafting its own simplex within the convex solid, and then it's like walking through the space towards the closest point until it reaches the surface of the convex solid. And then it's like, aha, we've reached the surface. This is the closest point. If that makes sense. So you can imagine like space-filling tetrahedrons throughout the convex solid, and it's kind of like it's got like a triangle within the surface, and it like adds a new point. It's like, we have to move this way as it's moving towards the test point that's trying to find the closest point. It's a really crazy way of doing it, but it works really well for Minkowski sums, because I can always find the farthest vertex in a direction, and that is the basic operation of this algorithm, is to continuously query what the farthest vertex in a specific direction is. So if you are going in this direction, what's the farthest vertex? Well, this is the farthest vertex in that direction. That's very easy to do for a Minkowski sum and regular meshes. So you can like walk within the space of the Minkowski sum mesh or the regular mesh and end up on the surface. And that is way faster than the infinity algorithm that has to come out from infinity and like walk a bunch. Quake and Blender. I wouldn't know. So this algorithm seems to be working in terms of the closest point. It seems like it works most of the time. No, not the closest point. Test point in part. Point, is this point inside the mesh or is it not inside the mesh? That part of the algorithm seems to be working, but then find the topological point on the surface that's close to the test point. That's the important part. That's replacing the old infinity fev algorithm. And that's not working. And that's why I'm trying to test. But man, it requires a lot of brain power. Which is why I need to do it first thing in the day when I'm like the freshest, sharpest. Okay, so this test failed. This test doesn't make any sense. Bruh. So we got... What's this? Who did 883? Is that this one? 883. That's this one. Right? Yes. Okay, so this one, did I run it twice? 012, 012. Huh? Yeah, okay. It's this one. 012, 012. Okay, so this 012. Simplex 3 012 was the result. And we want 1 2. And then this one this is returning 0 1, and we want 2 0 or 0 2. They're equivalent, I think. They should be equivalent. So it's the closest point to the origin. What if I flip it? But like, okay, if we imagine it, we have our triangle here, here, here. The right angle is on the back corner here. And I was testing negative, and it gave me this. If I test positive, it should give me a point, right? Let's just see what happens. X, go for it. It should, right? It can degenerate down. It's not doing it. It's not doing what I wanted to do. I'm going to read Trey's explanation. Reduce. Reduce simplex in general finds the closest point on the simplex to 0, 0, 0 and then removes the vertices which are not relevant to that point. Yes, which is equivalent to saying that this edge is the closest or this point is the closest. Point, removes the vertices. Yes. So if you triangle ABC and the closest point in the triangle to 0 is edge AB, then we return AB. Okay, my triangle might just be wrong. There's so many things that can go wrong here. How do I make it? Okay. Let me look at the triangle again. Excuse me. Did I commit it? Oh my god. Okay. Ugh. Negative, negative, negative. Negative, negative. Oh, did I do positive x? Am I stupid? Am I stupid? Am I stupid? Yes. Okay. Okay, I'm stupid. Hold on. Okay, so it's going, this is the right orientation. It's going uh like this. I drew it backwards. Okay. 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 How does that change things? So I'm testing here this point. That is 0, 1, 2. And I'm looking for 1, 2. So this remains the same. It was the other way around like this. 0, 1, 2. And it was still 1, 2. But then this one, we want negative x, and it goes 0, 1, 2. So we're looking for 0, 1. Whoa! Hold up. Did it just succeed? Wait a minute. Am I stupid? Okay. Shh, 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 shh. You failed. When I did positive x, it gave out the right answer. But that might be expected because the algorithm is like wacky backwards logic. I would prefer if it was normal forwards logic. Because, okay. So, okay. Remember the algorithm description. Reduce simplex in general finds the closest point on the simplex to the origin, 0, 0, 0, and then removes the vertices that are irrelevant. So, like, it returns the edge that's closest, or maybe the vertex that's closest, or maybe the face that's closest if it's a tetrahedron, or it'll just tell you if it's inside. If it's inside. And that's to the origin, not to a test point. So is this offsetting the simplex or is it offsetting the origin? So if it's offsetting the origin and I was doing, if it's offsetting the simplex and I was doing negative x, then it's still wrong, but it should be returning the vertex, shouldn't it? Okay, what if I have a more complicated point? What if I have like, oh, x, oh, wait, meant x, wait. Okay, so we have a triangle that goes here, here, and we're inputting this point, positive x. That looks like it's actually closest to edge 1, 2. But if it's negative x, then that's could actually be on the surface of the whole mesh. So I think this might make sense with negative inputs here. So, okay, if this is the input point and our triangle's here, 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 if you imagine this point is like just barely inside of the surface of this object, then you could also imagine that's hovering above the surface of the triangle and not like out here where the edge is the closest. And in that case, the return value of the algorithm makes sense. It's returning the entire triangle. It's saying all of the vertices are relevant to the closest point. So it's like exactly landed on the edge, but you can also say that's on the face, and all the vertices are relevant, and then only once it's out and off. So I think this might be correct. Maybe. I don't know. Okay, wait, we're doing times 2. Okay, that's wrong. Dang. Yeah, that is big wrong. I'm running out of brain here. Let's look inside. Reduce point. What point? People point. I forgot. This is A minus A. Where is okay? Here's how it works. So in the okay, so this is A1. This is mesh 1 minus mesh 0. In terms of the Minkowski sum, this is the mesh 1 of the Minkowski sum. This is the mesh 0 of the Minkowski sum. But we can just ignore the fact that it's a Minkowski sum and just query the mesh. In general, but in the Minkowski sum, the point is added to mesh 1, right? Where's the ooh? The lua. Okay, where's the query functions? Okay, here is query P, mesh 0, none point. So this is the test point. Query Q, we plus the point. It doesn't happen here. So point adds with mesh 1 and subtracts with mesh 0. What does that mean? So it's shifting the vertices of the simplex, which means it's not a test point, it's a negative test point. So the results I just got would have made sense if they were not multiplied by 2, but they don't make sense when they're multiplied by 2. Dang. I'm gonna write this down. So, test point, is an offset to the simplex So it is effectively testing negative point. Good writing down. We do like that. We do like writing down. Wait. 1, 1, negative 1. What if I change it? To 0? I'm just curious what would happen. Zero, 1, 2. It just. So this is like the a it's a direction perpendicular to the surface presented. Is that true? Is that true? I mean, it's true in this case. What about the 2 ones? 4, 4, 4, 4, 4, 0, 1. So 0, 1 is 0, 1, 0, 1. So a direct. So that's like. That's x. Negative x is that way. Then positive y. So it's like here. So this is like the next direction it wants the algorithm to look in. Do not have a firm grasp on the internals of this algorithm that my friend made. Which makes it tough to debug and see if I made any translation mistakes. I was hoping it would just work like the other algorithm. This push solve was beautiful. Mwah, chef's kiss. It just worked instantly. Well, not instantly. I did have to debug it a little bit, but I just kind of was able to guess my way out. Beautiful. I might want to actually change it to use the simplex. Simplex of context list. Actually, it's literally not that. It's a list of surfaces. It's literally not a simplex. It's a cutout of three-dimensional space where you're cutting off planes and then it's only in a certain direction. So it's I could use the same data structure, but it would be misnamed if I did do that. Rayback. Do I mutate it? Oh, where do I pass it around? Const as slice. I see. So this algorithm returns a new slice for unreachable 3 from iter. Yeah, so this would be useful to do as the simplex. But I would call it like push planes or something. Enum. C0, C1. So yeah, then I could actually have this input be also this the like strong type. But like it would just be noisy changes because it already works. I don't know what's wrong and I don't know how to find out. Because I just made this test. Does this work? Oh. I want to see it work. Okay. 0, 1 times 2 potentially. Okay. Let me think about that. So it's 0, 1. This is positive x, which means it's a negative x. Zero, 1, 2. Is it oriented? I wonder if the vertices are oriented. Let me try. Jesus, why would it do that? So this is 0, 1, 2. If I just do 0, it should return 0, 1, 2. Oh, geez. 0, 1, 2. Okay. What if I flip-flop them? I'm curious. What does it return? Zero, 2, 1, but the same test direction. So 0, 2, 1, which makes sense. I don't really know what I'm doing. Okay, so this was edge 1, 0, 1. Let's test edge 2, 2, 0, which should be negative z, which is positive z. Oh, am I stupid? Yes, okay. Edge 2, 0. Two, 0. Definitely it didn't succeed, right? Ooh, 0, 2. Interesting. So we asked it to do. I expected 2, 0, but it returned 0, 2, which for this algorithm is equivalent. Okay, so that actually makes sense to me because this is, I'm testing this point and it's giving me this edge. of our triangle as being the closest, as containing the closest point. And that makes sense to me. If I'm testing this point, that is where the closest point is contained on the triangle, is on that edge. No way. I put negative here. So what's going on? 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 So we have our simplex. Why don't I write it down? Let simplex equals to, it should be clone copy. Okay. Okay. And our test still works, right? Okay, let's look at this test. This test says 1, -1, 1. So 1, -1, 1. So that's this point. And it's saying the entire face is relative. Well, let's try it again. Maybe I'm trolling. No, yeah, it's saying the entire face is relative. Or relevant to the closest point, to the test point. And that does not make sense to me. So what if we move it out of the shape here? What if I just say ×2 here? Okay, what if we do 2 times here? It doesn't make sense. This is edge 0, you dummy. Do I dive in? Why don't I look at this like this? Um, so we're going here. That is what is happening. Is it saying like, meep, meep. I don't see how that can mistranslate. Does negative mesh mean negative farthest verts? No, right? It just swaps the stuff. Um, it's the negative of the negative. You you're grabbing the farthest vertices, but so when you swap the meshes, you're doing it opposite. Ugh, it's mental. I'm losing it. I'm losing it. It's coming out right here. So both of these are negative. So what does this mean? UV, UP. So, all right. We got our thing. U is P1 minus P0. So it points that way. V is P2 minus P0. It points that way. So we have our I'll make this U and this V. So this is like this. That's kind of hard. All right. U, V. Thumb is U. Thumb is U. So that's like that. So then U cross V. U cross V points up. And then U cross P. That's P is P0 plus point. God, I ran out of local variables in my head. I would have to recreate this from scratch if I wanted to understand it. So that only leaves one option, and that's comparing values at runtime with the Lua version, and seeing like, is this condition and this condition the same as when I run it in Lua? and it was killing me to implement the version I wanted to do. So I think I just make non-generic ones for each type of mesh, or not even each type of mesh. I really don't want to do that though. That's annoying, but like that's how I progress. Ah yeah 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 yeah. Ah yeah 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 yeah. Wow. Oh my god. I don't think I forced myself to do it. I should write it down though. Um, yeah, no. Compare run times. So this was trolling me here. Um, so to do. Uh, to do. Uh, make non-generic versions for physics, mesh, view, and Minkowski mesh. Since Rust doesn't want to let me call unsafe. So that's the plan. So I tried to do today what I intended to do yesterday, and I was able to think of two test cases that seem to pass here and make sense to me. But then the third case fails, and I think that it shouldn't fail, but I can't really see what's going on in the algorithm in my head. I can't like visualize it in my head. So I'm gonna need to just like compare left and right of the Lua execution and the Rust execution, and I just don't want to do that right now. So that's that. That's a solid 2 hours. I've really brought down the bar of how long I need to work on this because it is very mentally draining. Okay. Why don't we do some rbx-dom categorize chunks? Oh, oops. Skip. This dude is definitely recording from a vinyl record player. Just has a vinyl collection. Oh my goodness. So basically, I need a index of this crap. My oh my oh my oh my. Okay, just think less. Think less. Um, say less. So, I think this. Does this contain that? I don't know. I'm pretty sure this is indexed by that. So we will go like. We would blast this into this. It'd be like that. But so they'd already knows the type ID. Blast. Type name. I don't think we care. Number instances. So it knows what to do the DOM, right? Finish. DOM. When does it make the DOM? Oh, oh, it doesn't. Oh no, there it is. Header num instances. There it is. Okay. So then this, what goes in there? What about the other one? How does the other thing work? Type infos, type info. Oh, I was thinking about the serializer. Okay. Type infos. Yeah, okay. Why does this have this in here? I guess that's for the iter later, but you can grab it from there. Why is this? This is indexed by this. You can't get it until you do that. Ridiculous. See, insert type ID, type ID. It's duplicate information. Type info to type ID, but we should already have it. That is stupid. I'm deleting it. Oh, that's a what? Um, Instance type, prop type. What do you mean instance type, prop type? Did I mess it up? Prop chunk, type ID. And then it gets type info's type ID. Which is instance types and not prop types. So these are the same numbers. Very confusing. Why would it read that out of this? That doesn't make any sense. It's kind of a gratuitous optimization. Do I split it out into a separate pull request? It's data normalization. God damn it. Okay, so type info goes here. Prop info goes there. I'm just gonna do it all at once. We do not care. We do not care. The instance chunk data deserialization is delayed until all inst and prop chunks are collected. Inst chunk. Prop chunk. Nice. Now I have names. Okay, so type ID is also redundant. Prop name can be reread from here. Really, we don't expect to need any of that. Type name. Number instances. We don't really care. So this is guaranteed to exist. Property chunks for this class. Deserialization is delayed. Please. I think this is chilling like this, and we can just not do half this. So we only need the type ID. That's it. We don't need the name and blah, 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 blah. And then we do blah, 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 blah. Type infos insert. Uh-oh. I see. Okay, so this is gonna be in stages here. Um, we just did yeah, so this is going to be generated after, and you're just going to have it in scope already, so it doesn't really matter. This only this and this need to exist, and the rest of it does not need to exist, if I am not mistaken here. Pop, pop, boop, pop, baby. Uh-oh. I appear to have upset the gods. Type ID. Um, no, no, no. Yes. Although this will need to be created if the prop chunks come first, then that's unlucky. So I think we go like this. And then these are read out of the chunk. So like this. What? Can I satisfy from iterator? Why are you lying? Oh, jeez. Okay. So then now this goes over here. Where did it go? So type ID will come in here. Oops. Okay. Mutt. Is it mutt? Yeah, mutt. So I need get or create. So the methods, are these methods implemented on the deserializer? Yes. Should I make a get or create type info? Or should I make a new type? Why don't I'm just gonna make a little thingy. Struct type infos, and then that contains this. And then I can do function get or create. So option property chunks may appear before instance chunks. In which case this will be none. Yep. Self.typeinfos.entry type ID u32 or insert with. Type info. None. I guess I can derive default here. Default. Hello? Or default. There we go. Huge. Massive. Okay. So then type infos. Sure, whatever. Yeah. So then sum. Get or create. Yeah. No, we're doing like this. Type ID, and then dot inst chunk dot put equals whatever, and other stuff does not matter. Inline it. Why don't I assert that there's no duplicate instance chunks? I think that's a good idea. Replace. Is none. Assert. Duplicate instance chunks. Okay. Don't know why that's trolling me. Get or create. Yes, sir. And yeah, no more error. Get out of here. So type info dot prop chunks push. Yay. Whoops. We can just do this. Okay, well that's easy. So type info. It should all be there. Type info. I guess I can pass it. Type ID, type info. Prop chunk. So I need the old type back. Yeah, okay. Instance type info. Some. So this is not really type infos. This is deferred chunks. Uh-oh. I may not want to change this in a global sense. Just here. Deferred chunks. Oh, actually, no, I do. Chunks which deserialization is delayed. Okay. So now I want to reintroduce the old man type info. Yeah. So, and then this is not type info. This is also deferred chunks. Maybe I'll say type chunks. Cool. Okay, so then I'm working on it. And then I want to revert this, yoink the type, and then put it back. Cool. Okay. Actually, maybe we just leave that. Okay. So this is Type must be known. Oh, it's because I removed the goober there. Okay. Okay. Whatever. Wow. Probably type info comes out of here. Where is the lifetimes coming from? Give me that. Class descriptor, freaking the database. I don't know. Jesus, really? It just likes that? Really? It's just completely illiterate. I guess I'll say DB here. Be explicit. Okay. Well, isn't that fancy? This is type info, and it also includes the type ID. So we've already read this. Type ID. These are for sure the same. So what's been read off the prop chunk? Wah, wah. Type ID. Prop name. Cool. That's it. Okay. Fantastic. Fantastic work. Why don't I do a quick little format. Cool. Fantastical. So I have deferred decoding of the bop 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 bop. And so now I need to actually do it at the end. At the end of everything. For inst chunk in self dot deferred chunks dot type chunks. Yeah. Type ID and then type chunks in that. Now we get it. I get it. Let some inst chunk equals to type chunks dot inst chunk else panic no inst chunk for type ID and then for prop chunk in type chunks dot prop chunks gabagoo. So first we do let type info equals to decode self dot decode inst chunk mutt. Do we not need mutt? Self insert unlucky. Okay. I hope this isn't used freaking everywhere. Yeah, this is where stages would come in crazy. Okay. Decode inst chunk, question mark, semicolon. Then we do self.decode prop chunk. Type info, freaking, and then the chunk guy. Definitely for sure, definitely for sure. Type ID? I guess that kind of just is it? Why question mark? Inner error. Oh, it don't be doing like that. Okay. Result. Inner error. Question mark. Yes. And then now it hates me. So now we don't need this. Oh. Question mark. State. True. Self. Borrow of partially moved value. Ooh. Ooh. We actually don't care. We just don't care. We do not care. It's all going to get dropped in the end. We do not care. Inst chunk, inst chunk, inst chunk. It can be a reference. Like, it just doesn't matter. So decode inst chunk. It does write this goobert here. And it's also going to want this goobert here. But it's a subset of self. It's all instances by ref and unknown type IDs. So we do not need to do it. Yeah. I don't want to change the tabbing of this. I guess I'll just smash the hell out of it here. And instead of having self, I'll just have this one freaking list and this freaking database. Okay. Yoink. 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 You. Ah, crap. Unknown type ID, EE. Instances by ref. Random state. How about no? A reference to a goddamn hash map. Oh my god. And it is mutable? I don't know. Is it mutable? Apparently it is. Trolling. So instances by ref. We also want that here. Yar. Mutable reference. And then random state is something crazy. Yoi. Okay. So now we just change every single line of code that exists, and we're good. Is it this one? What did I just look at? Yeah, it is this one. Insert. Okay. Okay. But. Okay. Okay. So now we have self.instances by ref. Ooh. Yep. And we do this. And then there is a few stragglers here. Shared strings. Okay. Okay. It looks immutable. Database. Let me grab that. Shared strings. We can just say it's a slice. And database. Oh, brilliant. Thank you. Brilliant. Okay, so now we have these stupid functions on this stupid type. I would say self : and it's like 4 arguments. Whew. Instances by ref. Self that instances by ref. What else do you want? Self dot deserializer dot database. Insane. Okay, and then this one has 18 arguments. Same deal here. Mutt. Unknown type IDs. Shared strings. And that's it. 6 arguments. Database. Okay. 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 What do you mean unused formatting parameter? It's literally used. Is it trolling me? Like, Jesus Christ. Okay. Maybe it works. Wouldn't that be crazy? So invalid type is not real. Invalid type is not real. It oh, actually it's like this. If there's no inst chunk, that is actually straight up that error. Return error invalid type. Yay. Yay. Okay, and now everything works differently for sure. Definitely I didn't break the whole thing. Imagine if this works first try. It's so janky. It's like using indices and stuff. Yeah, no, I don't think so. Unwrap on a none value. Deserializer state 1563, G1563. Instances by ref. Decode print chunk. Okay. PRNT. Oh, parent. I see. Okay. It makes sense. There's like very little type safety for the stages of deserialization. Did it actually pass a lot of tests? That's crazy. Outstanding. Let's look at the overall diff. It's kind of interesting. I may have like forgotten stuff. There it is. Is that it? Yeah, that is it. So we're deferring the chunks. That's decent. And there's 7 million lines of code changed. So the other dudes expect the dude to exist, which is unforge. Instance add property. Hell is this? Oh, I see. It's a function. Yes. So it's like done there, and it's done its ding dong diligence. Instances by ref is basically not real at this point. So it's only this PRNT trunk actually. So I actually should be able to schnoink it off of this guy and just make it part of the final gimbal. Hash map with capacity. Header. We're dropping the header? Crap. Crap. 1 plus. Goobert. No, let's call it num instances. And I'll just like smack that. Tree reserve. Wait a minute. Can't I? Oh, it actually has the capacity here? I don't know. How far along are you in solving the 9 bugs? Yeah. I worked on it today. Um, it's hard. I've been working on it for a year. Um, I worked on some tests. Um, it's very mentally strenuous, so I'm only working at like 2 hours a day right now. Okay, so I think I literally just put off this chunk as well, and the yeah. Okay. So here, let mutt dom equals hash map with capacity self.num instances, and then this is not real. And then this is also not real. Unknown type IDs. New. We don't expect unknown type IDs. Huh? 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 Hash set. True. Me? Okay, so we're not using crazy daisies anymore. Root instance refs, I believe we can just jongulate that as well. And yeah, no such thing. It's all in the final Jabba-Jew. Gabagoo. It's me, Gabagoo. I really have to stop making up words. I keep doing it. Instances by ref. So the instance chunks make the junk. Yeah, so all I have to do is like return this or something. Yeah. So we can just have this doc here. And then instances by ref is here. GG. Oh, it's a freaking Uber comment. Okay, so it wants the instances to be decoded first, which is cringe. Wait, I can just not care. Wait, I just don't care. Wait, I'm goated. Okay, so amazing. And I can also steal it here, right? root instance refs. So wait, I just go like let some parent chunk equals self.parent chunk else panic. Come on. No parent chunk situation. And then we just go like, yeah man, yeah man, yeah man, and then it's great. So this is decoded. Yeah man, yeah man. So we're give ooh. Okay, it doesn't matter. Okay. 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 Get mutt. Children push. Okay. Instances by ref. Yeah. So we need the other. We need the other. Instances by ref. That one. Bow. And root instance refs, we don't actually need it at all. It should be maked right here. Subjects, parents, number objects, instances. Gobble D's. So what about this? That's okay. Okay. So it doesn't, no. Root. Okay, we'll do it here. That's a local variable. Let root equals vec new, and then we can return that vec I32 truly our time. Okay. So yeah, we there's light in the room. This is true. This is true. So I need to change this function name to ingest print chunk, and then this one is decode print chunk. So I need the old function signature. Pain. Did I leave it on the other goobs? Work. Profiling function decode. Yeah, I did. Okay. So this is ingest. Yeah, and then something. Type chunks, deferred chunks. Yes. So prnt chunk option prnt chunk. Yes. And then wait. All of these are literally the same. So deferred chunk. Yeah. prnt chunk none. Deferred chunk. No way. Cool. Okay. Wow, that's really cool. So ingest print chunk. We need to do the same goob as these goobs. Yeah, we actually care very little about what's going on here. Why is this still decode? I literally said change it to ingest. You idiot. Go. Chunk. Vec U8. Chunk. Deferred chunk. And I have code here, right? No, I don't. Where is it? So we're doing like this. The data. Print chunk. And then, wait, why am I doing that? Just do it like this, Gilbert. Can't I just, are you stupid? Clearly stupid. Why did I just do that? Go here. Impl deferred chunk. Function rest. Self. U8. Bam. Done. Self. Yep. Rest. Insanity. Why don't I do this to begin with? A little bit stupid. Okay. I'm working on it. I'm working on it. I'm working on it. Inst. Okay, so what is this doing? We're doing all sorts of. Yeah. Where's replaces none? Yeah, let's do like this. Zoink it and sploink it. And then I'll just fix it. Okay, so we don't need a comment every time. This, we don't need a cursor. Deferred chunk, start position, we can just say 0. And we're replacing the PRNT chunk. Duplicate PRNT chunks. Yeah, and then this is not real. This is not real. This is real, and that's it. We just go, and then it's in there, and that's it. Yeah, baby. Okay. Is this the Twitch stream? What is this doing? Immutable. Oh, true. Okay, so now, deferred chunks, print chunk, no print chunk, self, decode, print chunk, and then question mark, semicolon, definitely. And we got it. We got him. I got him, coach. Okay. Not mutable. Right. This goes here. And it's not mutable. Yeah. surely all problems fixed, right? Fix PRNT chunk. Ooh. Interesting. So I've passed many tests and then failed specific tests. Right. I forgot the most important part. Prop chunk. We know. No, not prop chunk. Wait. Who did this? Who did this? What's going on? Yes, that's right. It's not prop chunk. It is bop chunk. Inst chunk. Num properties. He says, let me know, man. Prop capacity. Bow. We don't get it from there anymore. Default properties, len. No. All we need is map class. No, literally just get it and you're done. Okay, so then the most important part, instance chunk, prop chunks len. Don't forget the most important part. Reserve properties. This is the like heart of the optimization here. Okay, so what if I do no fail fast? Wait, non-determinism. Did it? Okay, one target failed. Okay. What? Okay, let's look at the tests. Reference 0 null. That seems bad. So, okay, this is like rewrites. Okay, this is referent properties. Okay, I think I see. So we need to decode the instance chunks and then the print chunk and then the property chunks. Which does mean looping over the type chunks twice, but it's no big. Actually, it is big. Because then we have to vec it. Inst Type infos. This scuba dot into iter map. God, he's trolling me. Type ID chunks. We do this. Ooh, we need a question mark. Actually, I guess I can collect. Collect good, right? Result vec. And then right, I actually do need a question mark this. And then this goes up here. And then we're good. Yes. No field. Right. It's on here. Unexpected. Oh. Inner error. Very true. Give that boy a question mark. Type info. Right. That actually needs to be there too. Not used. Oh, I didn't know that. Borrow of partially moved value. This is a lie. Oh my god. Database. Okay. Decode purity before prop chunks. I've passed the tests. Signature look of superiority. Okay, so now I gotta run benchmarks, and the benchmarks crash my computer. So I'm gonna do it on my laptop. So we'll see if this is able to have a performance improvement. Why did the benchmark crash your PC? I think it's because of memory. It's just a hunch. I think it's like ECC memory, and it's doing something that like causes that to be relevant. It's either that or like the CPU has like particular. I don't know. It's very odd that when I run the benchmarks for this library, my computer crashes and nothing else. And it's not guaranteed. It's actually pretty rare to crash. Like a kernel panic, I don't actually know. The screen just goes black. Oh, you know what? It might be the power management. I did try doing it on your server or in a VM. No, I'm doing it on my laptop. Uh, eh. All right. I'm running the baseline benchmark. Base. Let's look at the overall diff. This is like really fast coding. I kind of just like throwing it together because I had some ideas while I was doing it of like, oh, what if I did this and this, but I don't even know if this is gonna actually have any merit at all. So just throw it together, chuck it together, pass the tests, and then run the benchmarks and see if it's worth like cleaning up. And I actually don't think I can clean this up very much. It's a little bit sad. Yes. So what this does is it makes it so that the properties of each instance doesn't need to grow and grow and grow, which every time it grows, that's an allocation, which is slow, and a mem copy of copying the data from the old hash map into the new hash map. So by delaying the decoding of the chunks, it goes like, oh, there's actually 36 properties. And then it just allocates once and it goes, fills them in, and it's done. Instead of like fill, oh, copy, allocate, oh, allocate, copy. Every single instance of every single instance, every time it decodes an instance or is adding properties to the instances, it has to like increase the size of every single one. That's possibly the main decode bottleneck, maybe. So if it is, we can expect to see a huge performance improvement. But also there's a lot of like mini allocations of like little strings and stuff. So I don't know. Maybe it'll just be a little tiny improvement. All right, so then the last benchmark. Last benchmark. Why is that crazy? All right, check out categorize chunks bench. All right, running the benchmarks. Oh man, I hope it's like 50% faster. That would be so juiced. If I had like 2 mega speed pull requests, now it's like the speed god. Laptop reveal. I guess that's kind of true. Like I use my laptop so little that you will only have seen it a few times on stream. I think I used it on Monday. What's the laptop running? Benchmarks for this code. Benchmark. Because my computer crashes. Crashy computer. Why don't you SSH into your laptop? That's a good idea. That's a good idea. How do I scan my network? Is it one now? I don't know. It is one. Oops. It says gonna find nothing. 0? I don't know. I don't know what I'm doing. Let's go. Okay. I guess I can just ask my laptop who it is instead of scanning my ports. Well, the benchmarks are done. 68 and 75? What? Why do I have like 5 IP addresses? What the hell? Okay, benchmarks, benchmarks, benchmarks! It says 10% for the one that matters. It says it's 10% faster. Your router allows Nmap on itself. I just told you I have no idea what I'm doing. So my laptop is both this and that. Okay. Okay. Nice. Okay. Great. Let's go. What is 87? Okay. 10% is nothing to scoff at if it's real, but like these benchmarks are known to be scuffed on Linux. Known by me. Cool. Does it use both? Does it ever use the type ID again? Never again. All right, let's just smash it in there. Continuation. Okay, so I believe it's time to smash. Squash. Okay, so um uh uh decode, defer, deserialization of some chunks to finish. Deserialization of some chunks to serialize a finish. Deferred. Deferred. Okay. Yeah, I don't think I need this. Cause the other crap is still there. Okay. Truncate. Rest. The rest of the chunks. So I've removed this. No, I have not. Okay. So it's no longer. I see. Very nice. Very nice. The type gets to stay with the exact same signature, but it no longer suffers from the bad data normalization. It's actually good data normalization now. %. I wonder if that's real. We take those, right? Prop name. What? It's the same line. Why is it saying it's changed? Oh, it's because it wanted to put the space here. Stubert. Strange. I think the profiling goes on the decode, right? Am I stupid? It must, because this is a tiny little goober function. Like, it don't be mattering. Yeah, I did that here as well. Pub super, yeah, okay. Yeah. Profile on decode. We go. We go. Fantastic. Okay. Uh, good. Uh, open pull requests. Pull request. Another one. So let me find the that I was. Yes. So this guy said, there are some performance optimizations we could benefit from rbx binary, being able to pre-allocate the number of properties for every instance. Yeah, man. Boom. Defer DC realization of some chunks to of prop chunks. As mentioned in Boom, growing instance properties is a bottleneck. Is a taxing it's one of the things that takes a lot of CPU in this decode process. Is a great load. Is draining performance. Vampire sucking. How do you, what's a word for that? Siphoning performance from the deserializer. This moves deserialization of prop chunks until after the number of properties is known. The approximate number of properties is known. The upper bound of properties is known. Regressing performance. Update readme. Regressing performance. It's siphoning performance potential. Procedurally growing. Why is that not a word? It's trolling me. Instance properties is siphoning performance potential from the deserializer. This moves deserialization. This PR moves deserialization of prop chunks until after the upper bound of properties is known. Period. Notes. There are a few panics added that could be turned into errors. All of them are related to missing chunks. Damn, this is a pretty juicer change, honestly. Any code I write is always ends up being a juicer to me. All the strings with more than one sentence, there's 2 spaces after the period. Why do you double space after each sentence? Because that's what you do. That's how you do it. That's how writing sentences works. One, two, three, four, five, six. How do you enable SSH? In SSHD, that's right. Is it open SSH? Oh, jeez. Oh, jeez. Okay, it's installed. Start SSHD. Okay, let's try that. Try again. Aha! Okay, I just needed to start SSHD. What's my password? Nice. I'm in. Quad laptop. Woo! Okay. All right. Oh. Check out master. Cargo bench. Run those benchmarks. Again. Gotta run it again. That was a great idea. Okay, I'm looking at the code. That should be turned into errors. All of them are related to missing chunks. What else is there to note about this code? Double spacing is a relic from typewriters is no longer the standard. Well, that's how I learned it. I did kind of cut it short. I knew more than I was letting on about double spaces. Yeah, I don't know. I just have liked it, I guess, as well. I understand that it makes me look old. You're truly old if you understand RN. That's not old though. That still happens. That's still a thing between Windows and Linux. It's a discrepancy that still exists to this day. Or are you talking about like carriage return, the like actual typewriter thing? All right, how we doing? We're running those benchmarks. Oh, that doesn't look good. Git fetch git checkout categorize chunks, and it's gonna be like, oh, you've diverged. Git pull. How do I like hard reset? You need to specify how to reconcile. How do you remove a branch? Git branch remove. Checkout. Oh, that one. Okay. Git checkout. Delete it. Did I just make a new branch? Okay. Git how to remove branch. D. Okay. Yeah, sure. Obviously. Cannot delete branch. Yeah. Do it. It's not. I don't. Like, do it. Yeah. Now do the thing. There you go. Benchmark. Not looking hot. We got that like 1% type situation going on here. Okay, so note that there are some panics that should be errors. As I wrote this quickly as a proof of concept. Why is serialize saying it's 8% faster? Literally none of the serialization code is touched. Okay, this is looking less good than the last benchmark. Like there is a benchmarking issue where the benchmarks just don't work. So this is the benchmark that matters. It's deserializing a real place. 27. I think it's like 5% faster. Huh. I was exactly right. Performance does not seem to have that significant of an effect performance. I'm seeing 5% improvement in miners haven deserialize on my laptop. Sick. Oh, I hope it works. Oh. I'm so good at making changes to this library now. I've really learned what's there in the library. All right, let's switch gears and do default for deal instances. Bobby. So Dom strong. I think this is also version 700. Is it? No. Maybe. I don't know. It directly, yeah, it directly depends on what version of this you're using. But maybe you can update it underneath. I don't actually know. I'm just not going to touch that at this point. Types strong types version is tied to database version. And then the list is exhaustive for this version. Every change is a breaking change. Yes, I hate non-exhaustive. Non-exhaustive. Okay, so what even do we need to do when we do? Two passes. That's right. So what I need to do is right here, generate the superclass defaults. So what the hell even is what I am doing right now? What even is going on? So I have these instances. Very cool. They're instances. Wow, they're instances. So we find a part. Wedge part, sure, whatever. Superclass is base part. So I have generated this code here. Oh yeah, I can do other stuff. I have generated this code here that constructs a default part. So it's like, that's the default. This value is false in the database. This value is 0 in the database. And it knows all of the default values. No way. But I haven't done this yet. So why don't I work on that instead? Because that is something else. Haha. So I'm writing code that generates code that compiles. Okay, so that'll be Earth right here. So convert enum. So I could either convert it to the actual real for real type and then debug it to get a string of the enum, or I could like reconstruct struct the enum name. Oh goodness. Yeah, no, this is not possible actually. I'm gonna need to yoink this. Enum. It needs more context. I mean, I can wrap it. Code generating code. You'll love to see it. Okay, so where does it actually generate the enums? It's down here. So I could actually generate the enums first, and then like do something crazy. Wait a minute. So really what I need to do here is scan this list for the value. This list for the value. This one. Cow. Stir? Oh, I see. Okay. Stir. Okay. Yeah. Okay. Stir. That's real. Okay. Self underscore. Let's go. I love underscore. Studio Script Editor Color Categories has this variant. Thank you, Studio Script Editor Color Categories, for breaking Rust code. EXPR value to string for real. Parse EXPR. Couldn't I like? Okay, I guess that makes sense. Okay. So I need the enum ident and the variant ident. The value actually, I don't care what the value is, but you have to have the value to be able to find those. So I could like make a little hash map and then run the enum collector first. That sounds pretty juiced actually. I think I can just do that. So push collector, So it's basically like pre-doing code generation. It doesn't matter. Okay, so I just had a thought like, oh, but not every enum variant will have a default value and will need to be generated. But like, who cares? Whatever, just do it. It would probably be faster. Okay, how do I do it on the fly then? I need this function, and that's about it. What about the ident for the descriptor name ident right here? Cool. So I can just do that. And I kind of already do that, right? So it's like prop ident type. Generate data type. Ooh, yeah. So it's this one knows if it's an enum, it's like, oh, it's an enum, and it generates the same thing. So it knows the enum name. Should these be the same thing? So like there's generate data type and then there's two tokens variant. Oh, they're kind of different. They only come together for this in one case. So I suppose I'm like generating a default value for every single property, which is the same like iteration case here. And then I'm doing it again here. Default struct fields extend fields iter. So fields iter, this is fields push, and this is prop. Okay, it's sorted. So I could stuff the default value in there because this is like transforming it anyways. Superclass field. Where is it? Fields into iter field info. That's just zoinks it off right here. We just delete everything. So default struct fields extend field iter. So I can just put more and basically do this crap. Data type tie, variant type fallback default value. So this is a are there enums that have no zero? Okay, how many enums are there? 536 enums. And how many equals 0 are there? Ooh. Ah. So, do we know anything about the default enums in the descriptor? Yeah. Where is it? Enum descriptor. Nope. Okay. Well, let's hope that BroBlocks doesn't try to make enums that don't have a default. I have a sneaking suspicion that they're going to do that. So I just need to generate the ident and the ident. And then I'm bing chilling. And I think I should do that in the property because every property needs a default value of some kind. So I'll change field info here to include default value. like literally this field value? I think so. And then I say here, default value, field value. And then we got him, coach. So then I have to like move this code right here. Let field. So no need for that. Fields iter. What am I doing here? Field info. Field info dot default value situation. Iter. Unfortunate. Oh, it works even with a reference? No, it moves? No, it's not. It doesn't compile. Okay. Default value. Yeah, so it's not going to like it. What if I say this? Ooh. All right. Cloned. Okay. Oh, wrong one. No, that is the right one. Oh, I just didn't have a bracket. Okay. Cool. So I moved the problem. Oh, prop real? So that was just for that. That's kind of nice. Where did it go? Why is it saying no? Oh. Every prop has a default value. For every prop, there's a default value. Why is it more code to do this? Why is it always more code? This is like doing it simpler and it's more code. Okay, so now we're doing it at the same time that we have detailed information about the prop. Yeah. Value. So I have to. I think there's two cases here. I think there's it's an enum and there's it's not an enum. If let enum equals prop dot kind data type else yeah match. Okay, we match. We do this. Match. You enum, you know. You know. You know. You know. You know. You may. So we match. And fill that match. Fill that match. Fill that match. Fill that match. Yeah. Semicolon. That's an L. So value, we just smash it through like this. Zoink. And that works. And then enum, we now have something else. Unimplemented. Huh. This is like very, very better than anything I wrote before. So we actually have variant type here. And, oh, easy clap. Okay. Okay, so I need this either way, I think. Because it's the default value. Oh. Okay, and then this is no longer real, but that's okay. We just live with it. Cannot move. We do not care, actually. So we do not care. Okay, so then now we have a cow. And we can grab that from the database. Database. Surely we have the database. Surely. Class descriptor. No database. Oof. Oh, it's up here. Goddamn. Okay. DB. Okay, we need it. Unlucky. Whatever. It just doesn't matter. Except it might. Oh, ooh ah ee ah ooh ah ee ah ooh ah ooh ah 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 ee ah. Variant enum value equals default value variant else panic data type is enum but default value is not enum. Okay. Okay. Stop. Okay. Wait, ident. Damn. Field name. Damn. It just worked. Okay. Whoa. So now we have ew. Can I just yoink that like straight up zoink it right out? RBX types enum yoink like that, or do I have to say like this? Is it? Yeah. Okay. Unlucky. Do we care? Okay, so now we need to do a similar thing. So database.enums.get huh? Where yeah, there it is. It's cow. Enum name. Expected enum name to exist. semicolon. Yeah, okay. Enum descriptor equals to this. Okay. Yeah, okay. So I think that okay, we have to iter find enum descriptor dot items dot find iter find so is it enum item? Oh, it's something crazy. Okay. Underscore value equals value dot value. Value. Okay. Sure. Okay, so that's find. So you must find the value of the default value variant. So this is another let else. Let some enum variant name underscore equals find else panic enum discriminant not found. Whee! Okay. Variant name. So we fix that up in our shop. Craft a couple of idents. We got it. We got it. Yeah. Okay, where is it? Fix name. Where fix name? Who did this? Fix name. Fix it. Enum. This is it. So fixed name equals this. Even variant name. It's already that. Semicolon. Ident. We have to make two idents here. So enum name equals enum name. This is a stir. Very good. And then this is the variant name. And then we go enum name, variant name, colon, boom, winning. Woo! Okay, so then fixed variant name. Oh dear. God damn it. Yeah. Okay. Humongous. So this is unreachable. Enums are handled by matching against the data type, something like that. Enums are handled by matching the data type. Cool. Okay. Let's run it. Run. Okay. Generate enum variants. default value enum. Generate enum default values. Yep. Okay, let's generate the code. Cargo run. Release. Bin. Roblox reflector. That's right. That's what I want to see. Yeah. Panic. Instantly panics. I wrote like 3 panics. Enum discriminant not found. I expected this. All right, run it again. Enum animation priority discriminant not found. What? 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 My brain is crazy. So Roblox is bad. This is Roblox is bad. So they're using an enum for something that is actually not an enum. It is associated constants. Roblox is bad. Who would have guessed? What can I do? I know what I can do. So if it can't find it, then it needs to generate a better fallback value. I think me thinks 60 hertz enum. Maybe is if it's allowed to not be 60 hertz. Then yeah, that's another. So it's more like presets than an enum where you're only allowed to choose the presets. It's just presets for a value that you're allowed to choose more widely. Okay, print more, print more, print more. Not found for class prop name. Ah, jeez. Oh, it's different now. What? It found something else? Is it this? Where's enum? Oh. Roblox isn't bad. This code is bad. Okay, so this is just going for an enum that doesn't exist. So I need to pick one. So let's see. If is that allowed? Are you gonna troll me? No, okay. Find value. Fallback default value generates U32 max if there is no fallback value. Underscore minus. All right, so just pray that all unspecified enums have a 0 variant. All right, I expect it's gonna panic again. Oh, what happened? Oh, it's printing the enum. Value, find value. Bop. Tracker LOD value. So, yeah. So it's just gonna have to pick one because it's it's not provided. I'm just gonna to basically randomly pick one. I'll just pick the one with the lowest value, I think. Okay, so let's see. Where's the strong? Enums. LOD. Tracker LOD. What? It has 0. What? Is that not? Is this not U32 Max? Oh, is this different? Am I stupid? What happened? Preferred text. Am I stupid? Preferred text size. Preferred text size. Preferred. Hello? Did I spell that wrong? I must. Okay, so there's no 0. I'm just gonna choose the smallest one and spam the console and be like, I'm picking here. I honestly 0 is picking as well. So I don't need this case then. I can just say this and then it will always it'll always not find it, and then it'll always print that it's filling in a default value. All right. So Print. Should I like warn? Inventing a default value. All right, so let default equals min by key like this v unwrap expected enum to have more than 0 variance. Come on, don't do that. Okay, so we have something here. It's a cow, and the ID. We could just print it. It just doesn't matter. Enum variant else. Oh, this is a diverging code path, so I can't actually do this. It has to diverge. All right, enum variant name equals if letting else enum variant name else enum variant name. Okay, what up? Right. Value. Enum variant value. Can I just smash that? I think I can. Sick. All right. We got the big one. Okay, so now we have enum variant name. It's fixed. There it goes. Okay. So it's going to print like a bunch of values that have no defaults. Inventing a default value. There we go. So we got 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0 type situation. That's what's going on. So potentially some of these are wrong, but like Roblox is not providing the default values. So, okay. Fix it. All right. We got enums. Generate. Okay. Generate enum default values. Okay. Does it pass a test? CD cargo test bin I don't know where the test is. Type strong, is it here? No. Dom strong, dom weak, wink. Test part inherits instance. True. True, true, true. True, very true, very true. Okay, so we need something. So this here, it says enums. Yeah, okay, so I forgot to do that. Oops. Here. Enums. Try it again. Oh, wrong. Strong cogen. Fix it. It should build. How many lines? 322. Minus 360. Isn't that cool? All right, do it be building though. Ah, I can generate a default part. Yeah, I can generate a default part. Let's go. So look at this test. This test passes. It passes the test. Part default. Gosh, it's actually wrong. The defaults are wrong. If we go to the definition of the default, can you go to the implementation? Oh, that was a mistake. That was a big mistake. By default. What? Where's the default? Oh, is it not? Oh, it just derived. Wow. Okay. Form factor part. Oh, wow. Form factor part, base part. Okay. So only base part has default. And there's no unreachable expression. It's not. Whoa. Look at how few underlines there are. Whoa. How many are there? 19? Okay. Instances. Unreachable code. Font. Material colors. Font. I have 2 more things to implement before I'm done. I also need to do this thing where it's generating the superclass defaults, because just because you're generating a default part, it might have different default values for the superclass properties than the superclass would choose if you were generating just that default. I'll have to do that. Holy smokes, that was productive. All right. Where is it? Strong properties. Strong defaults right here. Okay, the list. I just changed this. 700 LOL. And then this is all new. Okay. Oh. I passed the test. I came up with a good solution here. I was going to do a sort of 2-pass where it did the enums first and then it passed things from enum to structs, but this is like fine. Maybe even better. So, cool. Box, it just like hard coded to blue. Yeah, so now whenever it generates the code, it gives you a bunch of warnings. Enum button style discriminant not found for class style. Inventing a default value. Audio subtype default value music. Oh, I wonder if the parent default values. That's a zipper. Fantastic. Absolutely fantastic. I have cooked. Wow. So using my new Goober code, you can make a part and you can set the part name. Oh my God. I need material colors and font. Why don't I just do that? Material colors and font. So easy. Material colors and font is easy. Material colors. Surely. Oh. Ew. Right. You gotta figure color. Why don't I just say if it's not default, you're cringe. Let's see. Set color, get color. God damn it. It doesn't expose that information. Okay, so it always writes that. That sucks. Alright, I'm just gonna add a method. Len. Okay, now I can do this. Assert value dot len. I guess is empty is what I want. Cannot encode non-empty material colors. Okay. Are there any non-default colors? And then I just go like this. Material colors, new. And then we're done. Material colors implemented. Let's go. Surely, right? You says. Ah, very true. So true. Ah, there's non-default material colors? Oh my god, bruh. Really? Oh, oh. Alright, there's not even an iterator for this, so. That's kind of why I was doing my other pull request, was because like this thing was stupid. I've lost it. I'm done. I ain't doing all that. I did all this. That's good enough. I get a pat on the back. Ah. Hmm. 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 What else? Do I have anything else? I get a big check mark for that one. A gold star, you know? Let's go. Let's go. I get so many gold stars. I'm so good at everything. I just got a bunch of check marks. I did all the things. I did the work and the things. Urgh. Is this a real song? All right. Add shape. Okay, I can actually fix a little few more things here. This is unused. Unused. Found. Found. Oh, this is all one function. That's right. Good. Very good. So I refactored this and I refactored this, and both of them have iterators now. And they previously did not have iterators. Is there any cargo Clippy that I don't know about? Clippy. There's a few. Oh, there's only 35. I expected there to be more warnings. Square root 2. Oh, boy. Mm. Yeah. Is that a like hard error? Bruh. Deny approximate constant. You're kidding, right? Alright, so it's just like unreachable expression and then stuff I haven't done yet. Cool. Alright. I am very pleased. I've done 3 things today. I've got like projects. I got things in progress. I'm doing stuff. I kind of just finished everything though. In terms of the DOM, the rbx-dom, my latest pull request spurt seems to have come to an end. Other than the giant DOM strong project, which I'm not supposed to be working on. I'm supposed to be working on physics. But it draws me in, okay? Vec into, bruh. Man, all this stuff would be better with my new changes. Just saying. Except for font. Okay. I don't have anything else I want to do today. So I'm going to end the stream and come back tomorrow and do more physics. More physics. Yes, physics. let's see if I can plan out what to do tomorrow. So right. I've already planned it out, but I didn't write it down. I did write it down. I wrote it down in that. Make non-generic versions for physics mesh and make custom mesh because Rusty doesn't want to let me call it unsafe. Yes. So previously I tried to run the Lua code using mesh generics, but because of the consternations of MLua and like Lua in general, having like dynamic lifetimes versus Rust static lifetimes, I couldn't figure out how to shoehorn unsafe in, so it would just let me call the function that I know is safe to call. It would just spout compiler errors. So that was just like really frustrating and made me stop streaming yesterday, or stop working on it at least, work on something else. So I'm just gonna give up on that and instead make a version for the different types of meshes, because it's literally just a test tool. It actually does not matter. And then I can step through, compare the results, do that tomorrow. All right. We'll see you then. Goodbye.